These are trigonometric ratios, but not in some other form, but they are as the function of cot. So we have to write. So what we will do is that first we will write those things which we can calculate directly. So this is whenever these kind of question are asked, first we calculate those things which we can calculate directly. So what is the thing that we can calculate directly? Yes, what are the things that we can calculate directly? If you are given sine theta, so from sine theta you can directly calculate what?
Cos.
Cos. No. So from sine theta, directly, yeah, this one answer is also correct. But I am saying that you don't want to use the trigonometric identity. So then what can you calculate easy?
Ratios.
From sine theta, what you can calculate directly? The reciprocal you can calculate directly, right? So cosec theta I
So you
can,
mean we have to use the ratios here of
yeah,
the
so
sine
no, we don't have to use the ratios, right? We don't, so in this chapter we will not use the ratios, trigonometric ratio, we will not use that, right? P by H, B by H, A by B, B by B. These things we will not use in this chapter. So we will use trigonometric identities and some relation, right? So those are things we will calculate in this exercise. So as I have said, what is the first thing that we can calculate directly is the reciprocal. So in the first question, we want to calculate say sine, sec, and tan. So which one we can directly calculate?
sine.
So cot A is the reciprocal of what? The idea is that reciprocal we can calculate directly. Reciprocal is the first thing that we can calculate directly. So from cot A, what I can calculate?
From cot
Reciprocal
we
of
can
cot A is
calculate
what?
cosec.
So tan A I can
Oh,
calculate,
reciprocal of cot is 1
right?
by
From
cot.
cot A, tan A I can calculate. Tan. Yeah. So I have to calculate tan, right? So tan A would be how much? That would be 1 by cot A. This is the first thing that I can do, right? Without much hassle, I can always write tan A as in the form of 1 by cot A. So I have written tan A in the form of cot A. Is that clear?
Yeah.
Now you see that I have got tan A, right? I have got tan A and I have these relations, right? So you see that from cot theta, where this in the identities, in these three identities, what is the first? So where is cot theta? In which identity there is this cot theta?
The third identity.
Third one, right? So from third one, I can calculate cosec theta. Is that correct?
Yeah.
So cosec, let us try to calculate cosec theta, right? Cosec theta would be how much? This would be root of, or let me first write the identity, right? So let us write this thing, and then we will write, this is A. So cosec square A is 1 plus cot square A. So cosec A is how much? This is root of 1 plus cot square. This thing is clear, right?
Y-
Yeah.
Yeah.
And now you will ask that what is the use of
Oh, but
so what was
why
the use
put
that
loop
we
for
calculated?
him?
So this is cosec square e, right? And if this square goes in the right hand side, so this is x square is let's say 4. So if this thing goes in the right hand side, what it will become? It will become 4 to the
Root of
power half, which is root 4. So we have this cosec square e. So if this square goes in the right hand side, it will become clear.
Yeah.
So now you will ask that why did I calculate this cosec a? What was that? Look at the question. We needed sine a. So what is the relation between sine a and cosec a?
Sine square theta plus cos square theta is 1.
I'm asking cosec, not cos. Cosec.
Oh, cosec. Cosec square theta minus cot square is 1, right?
No, I'm asking the relation between sine and cosec. Relation between sine a and cosec a. What is the
Uh,
reciprocal?
is
So what is the reciprocal of sine?
1 by sine
Yeah, and what is that? What is 1 by sine?
cot. I mean cosec.
Cosec, right? So cosec a is the reciprocal of sine, right? So if I write sine a, if I write, we know sine a is 1 by cosec a, right? So now what I can do is that I can put the value of cosec a. This is 1 by root of 1 plus cot square. So I have written sine a as function of cot a. I have written tan a as function of cot, right? So those things are done.
And
Now
there is
I,
yeah.
yeah, so there is this ck which is right. So again we will either we can calculate from sine a or we can calculate from tan, right? So when you look in the identity, what is tan is related with what?
With cot, right?
In the identity, not the
In
reciprocal.
the identity,
Yeah, in the
it's with
identity,
C.
right? So then we can get seek from here, right? So, I usually call that seek. Yeah. Yeah. So if we write sec square a minus tan square a equals to 1. So sec square a is 1 plus tan square. So sec a is how much? Of 1 plus tan square. And I already know that what is tan square. Tan square would be 1 by cot square, right? This is
Yeah.
1 by 1 cot square A. So if I take the LCM, this is 1. So LCM is cot square A. This goes in here. So cot square A plus 1. So this is root of 1 plus cot square A. And root of cot.
I have a question. Why did we like write tan square with sec square? Because we have to find cot, right? So in terms of expressing cots, we should write sec square is equal to 1 by cot square.
Yeah. So you see that I already know this relation, right?
Yeah.
and I know that tan is related to cot, right?
Yeah.
So I just plug that value in, right? So I have used that thing. Whatever you are saying, I have used this thing in here, right? So in place of tan square, I have used this 1 by cot square. Either you use this in here, but we normally write the identity first and then put the value of tan. So is this clear? Is this clear? So you are saying that we write directly. Yeah. So you are saying that we directly write in here. We directly write sec square a minus 1 by cot square. This is what you are saying.
Yeah.
Yeah, we can do that also. So we can directly do that, and we will get the same result. So this is 1 by 1 plus cot square a. So this is cot square a plus 1 divided by cot square a. So what we will get, sec a is root of this thing, which is ultimately this. So yes, Rifa, can you hear me?
Yeah, your video was stopped.
Oh, my video was, yeah. So what did I do? I first calculated the reciprocal. So whenever these kind of questions are given, you first calculate the reciprocal and then use the identity
But
which really.
wouldn't we get confused because they're asking trigonometric ratios in the question, so
Yeah, so
because they're
trigonometry.
asking like there is trigonometric ratios too, right? So we can get confused between the question
Yeah,
and
so but in here what they have told, they have told us to express the trigonometric ratios in terms of party, not in terms of the sides of the triangle, EHB. They are not saying that. They are saying that right in terms of other trigonometric ratios, right? So they are not saying that we write it in the terms of the sides of the triangle. So you know that tan A would be P by B, cosec A would be sin A would be P by H. That is easy. But they are saying to express these in terms of what? So in terms of other trigonometric ratios. So that is the difference between those, right? One is in terms of the sides of the triangle. Those are trigonometric ratios. And these are in terms of other trigonometric ratios. So is that clear now?
yeah.
Okay, so please note it down. And then the next question is a similar one. So idea would be exactly same. First we calculate reciprocal, then we use the identity, and then we calculate the other ones. So please note it down.
So,
Done. Yes, for your voice is
nothing.
noted.
No,
Yes.
nothing.
Oh, okay.
You can scroll it a little up. Yeah. Yeah, you can stop.
Yeah, whenever you want me to scroll down, please.
Yeah, I have one doubt. Is it
Yeah.
possible if we write sin A is equal to cot A instead of cosec A?
Uh, Sine A, what sine A equals to?
1 upon cot A.
Okay, so you are saying that cot A is reciprocal of sine. Is that possible? So sine A is P by H. What is H by P? That would be reciprocal, right? P by H is sine. What is H by P? Yes, that is a cosec. So sine and cosec are reciprocal. Tan and cot are reciprocal, right? So I can write tan A as 1 by cot A, not sine A as 1 by cot A. If you are saying sine A is equal to 1 by cot A, you are saying that sine A is reciprocal of cot A. That is not correct, right?
Okay, okay. Oh, okay.
There is only one reciprocal, right?
Okay, so if sin A is equal to 1 upon cosec A, then you wrote sin A is equal to 1 by root of 1 plus cot square.
Yeah, so this one value we got from here, right? Cosec A we got from here. So I
Yes,
can,
so we put that value over there.
yeah. Idea is that first we'll write the reciprocal, then we'll use the identity, and then we'll see that what else we can get. That is it.
Yeah, I can scroll it down. Yeah, and one more thing. In this we found that sin A is equal to 1 by cosec and tan A is equal to 1 by cot A. So we can write sec square A is equal to 1 by cot A.
Cos is square. So sec and cos, they are reciprocals, right? Sec
Yeah,
is
cosine.
reciprocal. Tan is reciprocal of cot. But cot is reciprocal of tan.
Yes, so you wrote here cot.
Yes, yeah.
You wrote sec square A minus 1 by cot square A.
Sec square A minus tan square A, right? This is equals to 1.
No, the other side.
So this one you suggested, right? You suggested to me that I can write tan as 1 by cot, right? I can write tan from here as 1 by cot. In this equation, I can write it as tan as 1 by cot. So that is what I have done, right?
Yes, so what I'm trying to say is now we can like, now we did the reciprocal of tan A and sin A. So like that we can do the reciprocal of sec A and solve it the same way.
So if you want to calculate the reciprocal of sec A, that would be cos A, right? This would be
Yeah.
reciprocal. So what we will get from here? We don't want to find this cos, right? We want to find sec. So, yes. From there we can
Okay, so
calculate
basically both of them are correct.
which one.
The sec square A minus tan square A and sec square A minus 1 by cot.
Yeah. So we have just put the value. So we have sec square A minus tan square A. This is the standard rule that we have, right? Now I know that my tan is 1 by cot. This is the thing that I. So what I will do is that I will put this value, whatever this value is, in here. So sec square A minus tan is 1 by cot. But there is a square in here, right? So that would be square A equal to 1. So this, in place of this, I have used this to write. So this is what I done. Yes.
Yeah, but what I'm trying to say is now we wrote tan A is equal to 1 by cot A, the reciprocal of that number. I mean the reciprocal of tan A. So like that we can write sec square A is equal to the reciprocal of that is 1 by cos A. So we
So
can
in
write,
here, yeah, in here you could want to write 1 by cos square A minus tan square A equals to 1. This thing you are telling.
no.
Then how? What is so reciprocal of sec? Where do you want
See,
to use?
I'm telling sec A is equal to 1 by cos A.
Yeah. So,
Like that.
yes. So ck is 1 by cos. Yes, that is correct. Absolutely correct.
Yeah, so that is what I'm saying. The same way can we, instead of writing sec square A minus tan square A, can we write this instead?
Yeah. So this is relating sec with cos, right? this thing is relating sec with cos, right? This thing
Yeah.
is relating sec with tan. So what do we know from our previous calculation? Do we know cos or do we know tan? Which one do we
We
know?
know tan.
Tan. So then we will, which one will we use? This one or this?
We'll use sec square a minus tan square a.
Yeah, that is what we, yes.
Oh, okay.
So
No, because I got confused because here you used tan is equal to 1 by cot A, sin is equal to 1 by cos sec A, and then in the third part you use sec square a minus tan square A. I don't
yeah,
get
yeah.
it.
So because whatever we have to use those information which we have, right? So I don't have this cos A value. So that is why I cannot use this cos A thing. I know that what is tan. So then I can use it, right? Okay. So
Can I just
you wrote
write that
down
down?
which part?
The
This
C, the third part,
this one.
little up. No, up. Yeah, this one.
The So when we'll do the second question, it will become more clear, right? So step by step, whatever we have calculated, we will use that. Yeah, whenever you have noted it down, please.
You're finished.
So then we just good that you are asking your doubts, right? So whenever we have any confusion, and yeah, please don't hesitate to ask any question. Okay, so that is very good.
Yeah, and also our pre-boards are not on 3rd December. They're on 22nd December.
Oh, so pre-board is on 22nd, right?
Yeah, because we had
Yeah,
less
then
time, so they changed the day.
oh, but in pre-boards, how many chapters will come? So we have that
It's all the chapters.
all the chapters.
Yeah,
We are currently doing this thing. So how many chapters remaining? Trigonometry, then
there are like 4 new chapters, which
yeah. So tri
triangles,
triangle, probability we have done,
circles,
circles, and
applications.
application and area related to circle and surface area quantities.
Yeah,
It's one, five. Other way around. Okay, so the second question is that write all other trigonometric ratio in terms of sec A. Right, this is the. So what is the first thing that we can directly calculate from sec A? I have told you that what is the first thing that we can directly calculate.
the reciprocal.
Reciprocal. So sec A is reciprocal of what?
So it's cos.
Cos, right? So I can write cos A
Cos.
as 1 by sec.
Mm.
So I have written one trigonometric ratio. So I have written cos A in the form of sec A. Now sec A in the identity, right? In the identity where this sec A comes, in which identity?
The second identity.
So we can write the second identity and then we can calculate. So then we can calculate tan, right? So this goes in the right hand side. So sec square A, this comes in the left hand side.
1 plus tan square.
So tan square A is how much? This is sec square A minus 1. So tan A is root of sec square A.
Wait, don't we put sec square A minus 1 equal to tan square A? Don't we put the minus 1 as plus 1? Tan square A plus 1.
Yeah, so we want to calculate tan A, right?
Oh,
Yeah, because sec A is given, we want to calculate tan. So tan A would be in the left hand side, right? All the other things in the right hand side. Tan A we want to calculate. So now what we have done, we have written tan A in the form of sec A. So one done, second one done. Now from tan A, what you can calculate directly from tan.
the from tan
Yes,
sec
reciprocal from tan.
wait, are you telling to use the
Tan A,
identity?
you can. No, identity. I'm talking about
Using
the
the
first step
identity,
that
we
we
have
can
to
done.
say what is
Reciprocal.
reciprocal.
Identity we
Oh,
have used. Tan A identity we have used. So reciprocal. What we
1
can
by cot A,
calculate.
right?
So cot A I can calculate. A would be 1 by 10. Correct.
Yeah.
So then I already know tan A, so I will just put that value. This is okay. So now what is remaining? So you see that in A, I know cos A value, and in which identity this cos comes in the
Cos
first one.
yeah.
So I
Yeah, in
will
the first
write this. Yeah. So I will write. So I will write the first identity, that is sine square A plus cos square A, that is 1. So I want cos A I already know. So I will calculate sine A. It is 1 minus cos square A. And what was cos A? Cos A was 1 by sec A, right?
1
So
by
if
sec.
so this is 1 by sec square A, right? This is, so if I simplify this thing, so this is sec square A minus 1 and this sec square. This is sine square. So sine A would be how much? This would be cos sec square A minus 1 divided by sec square. This is a full square, so it will come out of outside of the root. So this is okay. So now what is remaining? Cosec A is remaining, right? So we already have sine A, so
In the
cosec
question,
is
we had to find out
yeah. In the equation, we have to find all the trigonometric function as the function of sec A. So that is what we have to find, right?
oh, so we have to do all the trigonometry. It's like
All,
all of
yes,
them.
yes, all of them. So this is sec A divided by 6 square A minus. So that is how we do these kind of questions. First we write reciprocal, then we use identity, and then using that one, whatever we get, then we again use reciprocal, and then again use identity. So that is the
So first we'll write the reciprocal and then we'll use the identity and then
identity. And then whatever we get, we will we'll get the reciprocal of
so
that.
yeah, we'll just put the value of tan.
Yeah, yeah. And then in the first one, whatever the reciprocal was, so we use that
Mhm.
identity and then
So,
again reciprocal. That is how it is kind.
oh, okay.
Okay, so any question in this one?
No.
Please now these are important. So what I will ask you is that please solve some of the questions and yeah, because this exercise is very important. This one is very important. And you'll have to
Oh,
practice these. Yeah, whenever you want me to scroll down the screen.
yeah, you can scroll down. Can you scroll?
Yes, noted. Yes, Rifa, did you note it down?
Yeah, noted.
Okay, so let us do one question. So the third question is, this one is very tough one, and we will do this. Try this at your home, right? These three, and tell me the answer in the next class, right? So this
Yeah, which one is tough one?
second, third, and fourth. Please try this in at your home, right? And let me try this one. So what is common in here? These two terms, what is common?
9.
9. And what is this thing? How much is this?
Square minus tan square.
Yeah.
Identity.
This is the identity. This is 1, right? So this would be 9. Okay, so I will stop it here. Please note it down and please try these second, third, and fourth question. Just try these once, and if you get stuck, so okay.
1 second. Yeah, finished.
Okay, so we'll stop it here, and maybe you have a class assessment, right? So whenever you leave, please take that class assessment, and yeah, and see you in the next class.
Allah.
Allah Hafiz, Allah Hafiz. Yes, hello Tariq, Assalamu alaikum. Yes, Tariq, are you there? Assalamu alaikum. How's your internet
Yes, sir.
working?
Walaikum salam, sir.
Yeah, so is your internet working fine today? And
Yes,
how's
sir,
your,
it's fine now.
so how did that dental checkup go?
Yes, sir, it went well.
Yeah, let us wait for Shafiz and then start class. Okay.
Yes, sir.
Okay. Hello, Tarif. Can you hear me? So Shahid is still not around. So we'll
Yes, I am
start.
hearing.
Yeah. So we'll start, and in the meanwhile, Shahid. Okay. So in the previous class, we calculated the magnetic fields of. So we calculated the magnetic fields of the straight wires, and we also talked about the magnetic field of circular wires at different angles. So this was the last thing that, right? So up until now, what have we done? So we know that for straight wires, for infinitely straight wires, the magnetic field is magnetic field is mu naught I by 2 pi r at this distance, right? And we also know that for a circular wire, the magnetic field is how much at the center. So let's say the current is flowing in this way. So we'll use the right hand thumb rule, and magnetic field is mu naught I by 2r, right? So let's say this is for for a semi-infinite wire, the magnetic field was what? So this was mu naught I by 4 pi r, right? And for this one, for a semicircular wire, right? For a semicircular wire, the magnetic field was how much at the center? This was mu naught I by 4r. And lastly, we saw that at certain angle, at certain arc length, the magnetic field was how much? So this was mu naught I by 4 pi r and theta. So this was these were the magnetic fields, right? Mu naught I theta 4 pi r, mu naught by 2r for full circle, mu naught by 4r for this circle. So now let us do this question, and this would be very easy to solve when we know these things, right? So today I want to complete some of the, yeah, at least this portion we can do. Let us solve this question. So this is the hairpin, and it has three parts, right? This hairpin has three parts, and we want to calculate the magnetic field at P point, right? The current is flowing, all of these currents are I, right? Is that correct, Tarif?
Yes, sir.
So, how many contributions would be there for this hairpin? So, this hairpin is in this form. So, how many contributions would be there? How many contributions would be there for this type of current? How many contributions?
Three.
Three, right? So, one
Yes,
is
sir.
this semi-infinite wire. This is one. Then we have this semicircle two, and then we have this one, which is three. So, three parts, right? And we are calculating the magnetic field at this point. So this distance is r, this distance is r. So let's say if we are in here, right? this is the distance that we are talking about. So V1 would be in which direction? Magnitude is semi-infinite wire. So magnitude would be how much? Mu naught I by 4 pi r. Right? Right? Is that clear? Yes, Tarif, is this clear? Yes,
Yes, sir.
Tarif. Yeah. And you see that the direction would be where? So if we put our current is going like this and we are calculating in the right hand direction, we are calculating at this point. So if we put our thumb in the direction of this thing and if we curl our thing, so something like curl our thing. So it is going inside, right? This is there, and if I put my finger like this, so this is going inside. In the right hand side, it is going inside, right?
Yes, sir.
Is that clear? So this is going inside, right? Okay. Now, how much would be the magnetic field due to second component? How much would be that? Okay, this is semicircle. So what would be the magnetic field due to semicircle?